Imagine turning empty desert into open water. That's Nevada's $16 billion vision: pump Pacific Ocean water 170 miles inland and flood the desert with 1,500 square miles of artificial lakes. An inland sea bigger than Rhode Island. But here's the catch. The last time a desert lake formed just south of here, it became one of the worst ecological disasters in American history. This time, it wouldn't be an accident. It would be intentional. So is this a bold engineering breakthrough or the next salt sea in the making? Here's the reality. The idea of pumping Pacific Ocean water inland has circulated for years in speculative studies and online concept explainers, often informally labeled the Little Pacific. The concept is commonly attributed to Ob Pro, described in online materials as a former U.S. Department of Energy manager who outlined how seawater could be redirected deep into the desert. The scale is genuinely insane. The proposal imagines 1,500 square miles of water suddenly appearing in one of the driest places on Earth. Nevada receives only 7 to 9 inches of rain per year on average. Moisture evaporates faster than it reaches the ground. There are no real rivers, no permanent lakes, only desert. Yet this project claims it could change that permanently. Here's how it would work. The system begins on California's Pacific coast with massive desalination plants. Using reverse osmosis technology, salt is removed from seawater, producing fresh water that can actually be used. That part already exists. The real challenge comes next: moving that water inland. The southern route would pass through existing infrastructure like the All-American Canal and Coachella Canal systems. These channels already transport water across the region, so the proposal is to integrate with systems that are already operating. The eastern route is far more ambitious. Water would move through the Mojave Valley along the mostly dry riverbed of the Mojave River. From there, it would climb through the Amargosa Valley before emerging at Nevada's border. Today, the Mojave River flows mostly underground, with surface channels remaining dry except during rare floods. Once inside Nevada, the water would spread across dried basins of ancient lakes, including the Amargosa, Ree, Big Smoky, and Monitor Valleys. These locations aren't random. Millions of years ago, they were real lakes. The land is naturally shaped to hold water, even though it has remained bone dry for thousands of years. The infrastructure includes 500 miles of new canals layered over roughly 1,000 miles of natural drainage channels. When fully operational, the result would resemble Nevada's own inland Mediterranean, at least in theory. The total price tag is $16 billion. The breakdown includes $4 billion for 20 gigawatts of solar panels, $4 billion for reverse osmosis desalination plants along the California coast, $6 billion for canals and water infrastructure, and $2 billion for pumping stations and power systems. To put the energy demand in perspective, lifting roughly 317 billion gallons of water to about 3,300 feet would require hundreds of megawatts to several gigawatts of power, depending on how fast the water is moved. The often cited 6 gigawatt figure applies only to rapid transfer scenarios, which is why solar power is considered essential. Both California and Nevada have abundant sunshine, so the energy is theoretically available. It's worth noting that this entire cost breakdown comes directly from the project's own estimates. In megaproject history, early projections almost always represent best-case scenarios, not final real-world costs. Supporters argue the project isn't just about water, but revenue. Desalination produces brine, highly concentrated salt water. Instead of treating it as waste, proponents claim valuable minerals could be extracted, including lithium, magnesium, boron, and rare earth elements. They point to California's Salton Sea, where geothermal plants already pull lithium from underground brine as proof the concept works. Beyond minerals, supporters envision agricultural expansion in newly irrigated valleys, booming lakefront real estate, and economic benefits potentially measured in the trillions. So, where does the project stand? Nowhere. As of today, there is no confirmed government funding, no regulatory approval, no environmental impact assessments, and no construction timeline. It exists entirely as a concept. The proposal has produced countless YouTube videos and headlines, but zero real progress. No politicians are backing it, no federal agencies are evaluating it. It remains an idea on paper, and that is likely where it will stay. The biggest obstacle is physics. Nevada's climate is unforgiving. Summer temperatures regularly exceed 100 degrees Fahrenheit, and evaporation rates are extreme. Any open body of water in Nevada loses liquid faster than almost anywhere else in the country. Even if these ancient lake beds were filled, the water would begin disappearing immediately. Constant refilling would be required just to keep levels stable. It's like trying to fill a bathtub while the drain is wide open. Then there's the salt problem. Without a natural outlet to the ocean, salt builds up over time. Salinity steadily increases, ecosystems collapse, and what remains is a toxic dead zone. That may sound familiar, because the same thing happened just a few hours south in California's Salton Sea. That cautionary example matters, but first, there's a larger historical context to understand. This isn't the first attempt to reshape the American West with imported water. For more than 70 years, engineers have dreamed of continent-scale plumbing systems. Nearly all of them failed. The story of the American West isn't only about settlement. It's about repeated efforts to rewrite geography itself. Engineers weren't simply building infrastructure. They were trying to change the climate. Throughout the 20th century, many believed that moving enough water could force rivers to flow where they never had before, turn deserts into farmland, and bend nature to human will. Nevada, desperate for water, was always eager for these proposals, and nearly all of them went nowhere. The most famous was the North American Water and Power Alliance, known as NWAP. In 1964, the Ralph M. Parsons Corporation produced a feasibility study describing a massive system made up of 369 components, including dams, pumping stations, canals, tunnels, and what would have been the tallest reservoir ever planned. The concept was staggering. Water would be taken from rivers in Alaska and British Columbia, carried across the Rocky Mountains, and sent through the west into 33 U.S. states, 7 Canadian provinces, and 3 Mexican states. For Nevada, this promised an entirely new future. Had NWAP been built, Nevada could have expanded cities, launched large-scale agriculture, and developed land that is now nothing but rock and sand. The full system would have stretched 8,000 miles, roughly the distance from London to Beijing. The cost was estimated at $100 billion in 1964, equal to roughly $1.1 to $1.5 trillion today. For comparison, that placed NWAP in the same league as the entire interstate highway system, one of the largest public works programs in U.S. history. The proposal required 200 million sacks of cement, 30 million tons of steel, 100,000 tons of copper and aluminum, and a construction timeline stretching nearly 30 years. Parsons argued the system would eventually pay for itself within 50 years through water delivery and electricity revenue. NWAP collapsed under its own weight. Canada had no interest in surrendering its rivers. Environmental groups began protesting before the project was even considered for approval. The cost was unrealistic for the era, and interstate politics turned coordination into a nightmare. Historian William Devoe later described the plan as defeated by its own grandiosity. By the 1970s, NWAP was effectively dead, filed away under a folder labeled "Maybe Someday." But it was not the only dream. Throughout the mid-20th century, engineers repeatedly proposed trunk canals extending from the Columbia River in the Pacific Northwest. The goal was to redirect part of that region's abundant water into Nevada, Arizona, and California. Engineers produced pump designs, canal models, and extensive irrigation calculations. Like NWAP, these plans stalled. Costs were too high, interstate disputes too severe, and environmental opposition overwhelming. Another recurring fantasy involved pumping the Mississippi River west. The idea was to treat the river like a liquid conveyor belt, move vast quantities of water across the country, and transform the Great Plains and nearby deserts into fertile oases. Once again, the math was done. Once again, political and economic barriers shut it down. Every few decades, continental water transfer dreams resurface. They generate headlines, investor presentations, and political excitement. But engineering reality, ecological consequences, and fragmented politics always win. Failed megawater projects share common traits: extreme ambition, interstate conflict, unclear funding sources, and political fragmentation. Here's the key point. Not every massive water project failed. A few succeeded, and they explain why Nevada's Pacific Pipeline likely will not. The clearest example is the Colorado River Aqueduct. Conceived by William Mulholland and designed by Frank Weymouth, it became the largest water supply line in the United States at the time. The aqueduct stretched 242 miles from Parker Dam in Arizona to Lake Matthews in western Riverside County, California. A $220 million bond was approved in 1931. Construction began January. The projects that succeeded shared several clear traits. They had unified state-level political support, incremental construction stretched over decades, realistic engineering within proven technology, and economic benefits strong enough to justify massive costs. The failures looked very different. Continental-scale visions, international conflicts, no stable funding structure. Nevada's Pacific Pipeline fits this pattern exactly. It faces interstate water politics, lacks federal backing, depends on speculative revenue, and remains untested at this scale. It follows the failed model, not the successful one. The real warning comes from California's Salton Sea, a textbook example of what happens when a desert lake is created without planning for consequences. In 1905, engineers were building an irrigation canal from the Colorado River into California's Imperial Valley. Everything went smoothly until the river flooded. Water tore through an earthen dam and rushed into a vast depression far below sea level. For 2 years, the flow continued non-stop. When engineers stopped it in 1907, a new sea had formed permanently on the map. At first, it seemed miraculous. Resorts appeared. Marinas followed. Fishing camps thrived. By the 1950s, the Salton Sea was a booming tourist destination. But the sea had no outlet. Every drop that entered remained trapped. Agricultural runoff arrived loaded with pesticides, fertilizers, and salts. Desert evaporation was relentless. Water vanished into the air while salt stayed behind. Salinity rose year after year, eventually exceeding ocean levels, then doubling them. Fish began dying, first small die-offs, then massive events. Thousands of dead fish washed ashore in rotting piles. Algae blooms spread. Oxygen levels collapsed in the heat. Fish suffocated. Hydrogen sulfide odors traveled for miles. Tourism collapsed. Today, the Salton Sea is an ecological disaster zone. Falling water levels expose lakebed that releases toxic dust filled with salt, pesticides, selenium, and heavy metals. Poison dust storms sweep nearby communities. Mostly low-income families now suffer soaring rates of childhood asthma and chronic respiratory disease. The Salton Sea was accidental, but Nevada's Pacific Pipeline would recreate the same conditions intentionally. Endorheic basins, no outlet, extreme evaporation, rising salinity. It is the Salton Sea by design. Nevada's water challenges are real. The Colorado River is strained. Lake Mead keeps falling. Las Vegas and surrounding communities face long-term pressure. But the solution is not pumping the Pacific Ocean 170 miles inland. Existing solutions like recycling, conservation, infrastructure upgrades, and cooperation address Nevada's crisis. So what do you think? Should Nevada gamble on a man-made sea or stick to proven solutions? Comment below, hit like and subscribe for more bold engineering stories.